Hi, I'm Kim Shepard. This is Lesson 8. We're going to start with video 8A. Lesson 8, we're going to start looking at two variables and how they might be related. So to motivate that, we have an example to start off with where we have data from the U.S. government through its direct loan program, makes direct loans, directly to college students. We're going to investigate subsidized loans where the interest is paid by Uncle Sam until you're out of school. And so data was collected during a recent fourth quarter, and we took a simple random sample of 62 schools. This was drawn from the population of all schools that were granting loans. We did add Cecil College into our data set since that's of local interest for us. And we have a couple of variables that we're interested in looking at. We're going to look at the number of loans that each school granted, as well as the value of those, the loan value. And so for each school in the data set, we have recorded the number of loans as well as the loan value. So one example that's in the data set is Cecil College, which issued 178 loans in the fourth quarter, and the total value of those was $295,818. So for planning purposes, the government would like to explore the relationship between number of loans and loan values. It's fairly easy to estimate how many loans will be granted in a given semester since those trends are fairly stable. However, the loan value is a bit more difficult since tuition rates vary, tuition increases, enrollment changes, and so on. So by the end of Lesson 9, we'll come up with a model where we can predict loan value based on the number of loans. So eventually we'll work our way to coming up with a model that will explore that relationship. So this is an excerpt of the data. This data set is available in StatCrunch. We have the name of each school, the number of loans, and the loan value. And so whenever we're looking at the relationship between two quantitative variables, and they have to be quantitative, the first decision that we need to make is which is the variable of interest. And so in this example, the variable of interest we'll call the y variable. When we end up making a graph, this will go on the y-axis. And the variable of interest, another name that you'll see in statistics that we call this, is the response variable. And in the direct loan example, the variable that's of interest to us is the loan value. So y for this one will be loan value. Back in algebra, you might remember that this variable was sometimes called the dependent variable. Okay, how about the other variable? So the other variable we're going to call the x variable, and this is the variable that we're going to use to help explain or predict the response variable. So this is often called the explanatory or the predictor variable. We'll say it's the explanatory variable. And in this example, we're going to see if we can use the number of loans to help predict the loan value. So the number of loans we're using to help explain loan value. So number of loans is the explanatory variable. So whenever we have two variables, that's the first decision we'll make, is which variable is the variable of interest, which is the response, and which is the variable that we're using to help explain or predict that variable, which variable is the x variable. So we'll practice this a couple more times. Okay, suppose that we would like to predict a person's income based on their age. If that's the case, we'd like to identify which is the response variable and which is the explanatory variable. So the variable of interest to us here is the person's income, and we're using age to help explain their income. So for this problem, income would be the response variable, or y. Whoops. This is the response. And X would be the person's age. This is the explanatory variable. And in a future lesson, we'll see a graph like this. This is called a scatter plot, where we put the explanatory variable down on X. So these are the age of the people in the data set. And we put the response variable up on Y. So on Y, in this case, we have the incomes. And we're trying to see if we can use age to help explain or predict a person's income. All right, one more, I think. Okay, in this last one, Cecil students obtained the price of a textbook that they needed for the current semester. Students recorded the price of their book at the bookstore and on Amazon and on eBay. And the goal was to investigate to determine which website most accurately predicted the bookstore price. And so in this one, if we wanted to, again, identify the response variable and the explanatory variable, let's start with the response variable. We're interested in the bookstore price. That's what we're ultimately trying to see how the other variables affect that. So our response variable in this case would be the bookstore price. And now in this example, so this is the response. We actually have 3 variables, not just 2. We're interested in how Amazon prices might relate to bookstore prices and how eBay prices might relate to bookstore prices. So in this case, you actually have 2 potential variables that you could plot down on your x-axis. We could look to see how Amazon prices help explain or predict bookstore prices. We could also use eBay prices to see how they explain or predict bookstore prices. We wouldn't do both of those at the same time. We'd probably make 2 separate scatter plots, and then we could see how those different relationships look. So for X, there are 2 possible variables. You could use Amazon prices or eBay prices. And so either one of these you'd be using to help explain or predict bookstore prices. I think there's one more slide. So just to summarize what we've looked at today in this video, the variable, whatever we're predicting, that's the response variable. In the last example, we were trying to predict the bookstore price. That was the response variable. The explanatory variable X is what we use. Sorry, got to read that again. We use the explanatory variable X to explain the variables of the response variable. And again, in the last example, we were trying to use, let's say, Amazon prices to help explain the bookstore prices. You must properly name the variables and understand their roles in regression analysis. If you switch the variables, the whole analysis will be backwards and it'll be faulty, won't make any sense. So we're going to do a lot more after we just identify 2 variables. We'll go on and look at scatter plots and build models. But if you don't have this first part right with identifying the 2 variables, then everything that follows will be faulty there. So got to make sure that we have this correct. Response is the variable that you're predicting. The explanatory variable is the one that you're using to help explain or predict. So that's the end of this one.